Hello and welcome to ICND1, the first half of the Cisco CCNA certification program. I'm Larry Coldiron and I will be the instructor for this class. Uh, First of all, a little bit about me, certifications and experience, and why do this? Uh, why do this with me? I've got some experience doing these courses, Cisco courses, as well as some other certifications, as you can see here. I've been a CCNA since 2002. I got the CCNA security certification in 2009 and then the CCNP in 2011 when I finally figured out that I could renew my CCNA by progressing in the Cisco field, by moving up in the certification world. When you do that, each of your higher level certifications in Cisco automatically renew all your lower levels. So if I take a CCNP test and I have a CCNA, then I get credit for the CCNP test and it also renews my CCNA. So one of the other ways to maintain currency without having to retake the test, as you can see, 2002 until 2011, I was pretty dense for a long time, but I finally figured it out. Other certifications that I have had, I've got an A+, which I got in 1997, I think. Network Plus, Security Plus. I've been an MCSE since 1999, which is now MCSA. And I have been current through Server 2012, including all of the Active Directory certifications. Certified wireless network analyst, and then previously I've been a certified ethical hacker. It just became too hard, too much, too expensive to keep all of the certifications current, so that one lapsed. I also have had in the past, actually I guess it's still current, a network certification. I've been a network administrator at ECPI University and at Blue Ridge Behavioral Healthcare, both in Roanoke, Virginia. I was an instructor at ECPI University in the IT department for about 19 years, ECPI University, Roanoke. I also teach for LeaderQuest online, and I have taught courses for the SAGE group. They generally contract with in the courses that I did for AT&T. I done CCNA courses for them as well as fiber optic courses. So what's in this course? The course topics: basic networks, basics of networking, basics of Cisco devices and commands, setting up an IPv4 network, an IPv6 network. IPv6, obviously, the thing that is coming, and it actually is finally coming now. It's been coming for about 20 years now. Infrastructure services, LAN switching basics, routing basics, NAT basics, maintaining the network infrastructure, network security, and then troubleshooting the network. What I want to do is drag over, what we're really going to do is go through, let me drag this over here, the objectives for ICND1, interconnecting Cisco network devices, part 1, test 100-105. And the test, 90 minutes, 45 to 55 questions, and they different question types. And we'll kind of try to discuss the kinds of questions that you might see, not the specific questions, because nobody can predict that for you. But what each part of it counts: network fundamentals, OSI TCP models. If you have seen those in Network Plus, then you kind of have an idea. Otherwise, we'll go through that. The TCP and UDP protocols, the two primary transport layer protocols, the impact of infrastructure components, the Cisco three-tier technology. We'll talk about that, a way that they use to set up networking on a large scale. Network topologies, how a topology is what it looks like, and we'll talk about all those. Troubleshooting methodologies, troubleshooting IPv4, subnetting, kind of not most people's favorite topic, but we will go through subnetting and we'll look at some what I consider shortcuts for subnetting. IPv4 address types, private IPv4 addressing, IPv6 address types that we're going to use there, and then LAN switching fundamentals. Routing and switching is the title of the certification, so there is a significant amount of switching involved in the certification and in the management of the network, as well as in routers themselves. So we will look at switching fundamentals, a number of topics there. Look at the frame format, the cable issues, collisions, duplex, VLANs, virtual local area networks, trunk ports, all these things, terminology that we will go through as we go through the course. And then after switching, we're going to go through the routing fundamentals. The second half, the ICND2 course, goes into a number of these topics in some more detail. And Cisco and Microsoft used to tend to do that too. Is we'll introduce something, we'll give you the fundamentals, and then in the next course we'll go into it in greater depth. So in these things, components of the routing table, how do we get the routing table populated? And the routing table is the thing that's going to send the data from point A to point B when we look at these things. Infrastructure services, DNS lookup domain name system, which is the process that allows us to type in names instead of numbers when we want to go to a website. We do those things. And infrastructure maintenance, licensing, logging, time zones, things that can become significant when you're doing some troubleshooting, and time zones when you're looking at logs. What happened to the different devices? Do we have the same time? Do we know what time things happened to them? And then some device maintenance on these things, upgrades and recovery, recovering configuration files as well as the operating system can become a big deal. You need to know how to do that in case you need to do it. It's not the most fun topic in the world, but it is a challenge at times. And then troubleshooting tools, things that you may or may not have used, ping, trace route, terminal monitor, which is going to be specific to the Cisco, and then the log events. Logging. We talk about logs, we do logging, and then a lot of times we don't go back and do log analysis. It's one of those things, if you're not going to do the analysis, there is absolutely no reason to do the logging. The only thing it's going to do is take up space. So this one, back to overview and networking basics. So the first topic here, and the first one, what is a network? And networking, probably everybody has done some type of networking. Many of you do social networking. And in a network, the objective is to connect users and to share resources. What we need in order to do networking, and I kind of become a kind of a cripple here, try to do some use a pen here. So we have to have a resource. We have to have something that somebody wants. So we have a resource, and I'm not a real great writer. I have horrible handwriting. We have a resource. We have somebody that wants something, so we have a need. And then we have to have a common communications. So we have to have a common language, and these are going to be our protocols. We have to have somebody that wants something and need, and this will probably be in the client server, the client. And then the resource is going to be shared someplace in the client server. What we're going to do, the thing that we are doing with the Cisco devices is allowing these entities to connect with each other. So the network here, what we're really looking at in a great deal is what goes on here in this magical cloud. What we're really going to look at large enterprise offices, if we want to break our enterprise network up into multiple entities so that we can communicate, create security, and communicate these things. So a network, connecting users and sharing resources is what we're doing with these things, with the network. So a network perspective can be a big deal, is a big deal with these things. And a home user here, the perspective from the home user is that we're going from our laptop or our PC, maybe even wired or wireless, to our wireless router that we have in our house, to our cable modem, DSL modem, and then we go to the internet. Once we get to the internet, we have the different resources out here, the web pages that we're going to go to, or maybe we're going to go to our Dropbox or our Google Drive, whatever else, but we're going to get to a resource of some sort out here. So home user, kind of a basic, let's get to the internet and use the resources. The enterprise view can be a little bit different, and I know there's kind of some hokey images here, but we have an enterprise, and we show a single PC. We would have multiple PCs, multiple switches going to the enterprise network. We may be connecting location 1 and location 2. We may have a headquarters activity and then a remote office, for instance, that we're going to connect, so that the remote office can access resources in the headquarters activity. What we're going to do is we're going to look at managing this enterprise network so that we keep it available and secure. Some terms that you hear in security, the CIA, confidentiality, integrity, and availability. We're going to at some point be responsible for most of those things. Some of the devices that we're going to talk about will be a hub, switch, bridge, router. Hub is an old device, legacy device, and legacy obviously means old, that we hopefully are not going to use anymore. Switch is going to be the device that we're going to do a lot of configuration. And if you remember the ones that we talked about in the earlier objectives, switch and the routers were the ones that were on the list. The bridge is kind of the original switch, and sometimes the switch is going to be called a multi-port bridge. And then a hub was actually the originals. We'll talk about how each of these different pieces of equipment operate and interact with the network as we go through the course. A very basic network, and I've introduced some terms here that we will get to, layers. And when we talk about the OSI model, Open Systems Interconnect, or let's just say the model, because we're going to have two different models, we have what's called a layer 1 device. And what we're talking about, a very basic network, we have computers here, and it just shows a single piece of wire, and that's really what it is a single piece, and originally it was a piece of coax that each of these devices connected to. So they're all sharing the same media as we connect the devices together. And I had an equal sign here, a hub. What a hub really is, it says everyone can hear you, just like if we're here. What a hub is we take this single piece of coax here, draw a box around it, not a real good box I realize, shrink it, and then we have a hub. So a hub internally is what, and this is going to be called a bus, is a bus. So that we have Henry and Mary here. Hey Mary, if George was connected to this, George would also be able to hear this conversation. And that's what everyone can hear you when we're working at this level. Every device sees and hears the traffic from every other device. We had a switch, that was one of the devices that we talked about. A switch only accepts traffic that is destined to the device that's connected on that particular port. What this shows is Henry, hey George, so that they're going to connect. It's going to go to the switch, and the switch says, George isn't connected to my device, so I'm not going to send it out. And if we had the bridge, a bridge would have multiple devices connected to it. A switch is going to essentially do the same thing. We talk about layer 2, we're going to have segments. These terms are going to become significant as we go through the course. This is just a way to kind of get some terminology into it early on, so that keep hearing the terms and hopefully they'll make sense as we go on through. Routers find networks. We're going to talk about later how we find the individual device, but the routers are going to be the devices that are going to find the networks for us. So routers are going to divide things, and we're going to have this thing called a broadcast. That routers are going to stop broadcast. Go back here, what we would have here is called a collision domain. A collision domain going into these things. So these, and then the hub and the bus here, because the hub is the bus, all have a single collision domain. So we can have collisions going to slow things down. When we introduce the switch, each port on the switch becomes a collision domain. So what we wind up with the switch is a situation that we cannot have a collision domain. So we add the switch segment, it creates collision domains, and the broadcast domains are going to be things that are related to IP addressing, and routers are going to be the devices that will stop broadcast. They find networks. We can filter them using the IP addresses, the layer 3 addresses. As we go through, we're going to have two different types of addresses. We're going to have the IP address, which are not permanent, and we're going to have permanent addresses, which are going to be called MAC addresses, media access control addresses. No broadcast, and a broadcast is something just like in a broadcast radio, goes to everybody. So broadcasts go to all of the stations that are within that broadcast domain. Can create a lot of traffic, and if you're on a Windows network, Windows machines can't not broadcast if you'll set up a sniffer for those. So down here it says, I love shouting, hey everyone, and this is going to be the broadcast. Even though it's a switch, creates collision domains, but it is a single broadcast domain. So broadcast goes to all of the connected stations. The router stops that, and over here we have, who was it, Mary is sitting here not seeing those broadcasts. So we stop them with a router. Communicates among networks, and networks could be things like locations, different physical locations, could be buildings, could be rooms at ECPI. We broke our campus up into rooms, and each room was in its own broadcast domain on its own individual IP network. A couple of different new terms there, terms again, that IP network, collision domain are going to be on those things. And this is just an image that's got a number of devices. We have hubs, routers, and switches. Those are the things we're going to be predominantly concerned with. And not predominantly, those are going to be the devices that we are concerned with. We're going to be concerned with routers and switches. Hubs really don't have a lot of configuration that goes on with them. A typical network today, we have switches, not hubs. So the switches are going to create a situation where we're not going to have collisions. If we have collisions, it's just like if you're out in the highway and there's a collision. It's going to slow things down. So we don't want that to happen. And in that case, we're going to have a network using switches that doesn't have collisions. And then the router is the device that's actually going to send the data to either our ISP, if we're going to the internet, or maybe to a different location within our enterprise network. Could be a different room, could be a different physical location, could be a different building. However, we have our devices configured. Routers define the other resources when we do these things. So what we talked about here, a little bit about me and why this course, the course topics, what we're going to cover. We looked at the network perspective, a little bit about network devices, and then what a typical network in use today looks like. We're going to be using switches, not hubs. The devices that we're going to be concerned with are going to be the router and the switches, the things that we're going to learn how to configure in this course. So I'm going to quit now. We're at the 20-minute point. I'm going to try to hold these things down into bite-sized sessions as we go through the course. So I hope that you'll join me in the next lesson.